Okay, hello everyone. This is going to be a brief video here looking at the software interface that we have for running this wind tunnel. So that software interface is actually Windows XP does really not like this. Arrange icons by, there we go. I'm trying to just drop it in the middle and it's not letting me. There we go. It's this icon. Aerolab EWT, Aerolab Educational Wind Tunnel. It's a lab view program they threw together that runs this thing and takes data and whatnot. It has some bugs. I will explain the important ones to us as we go through here. But this is what one of the two modes of the software looks like. It has a second mode, which I'll show actually right now. So this mode is for measuring forces and moments, right? Normal force, axial force, pitching moment, and it has this handy dandy graph that measures them over time. If I hit tare balance for a second here, we'll see that these lines all go to zero, but more importantly, that transition point is slowly walking its way across the screen. So this graph will give you a short time history of what these forces and moments look like over the course of the last 20 to 30 seconds or so. The second mode of the software really only changes this left-hand side of the screen and gives us a couple more options over here. And that is if we're measuring pressures instead of forces. So if we switch to the pressure mode, we hit Start PTA, Pressure Transducer Array, and we get a different looking graph. This is just looking at pressures. So all these red lines are pressure levels. The higher the line, the lower the pressure. The lower the line, the higher the pressure. And we have potentially 24 different pressure sensors that we'll be using. This is not the version of the software we're using for measuring forces. This is used for measuring pressures, and a lot of them. And those will all be measured via tubes connected to this box down here once we get to that part. The only thing to note about this that's kind of unique is that we can change, this doesn't auto range the axes. We have to manually set a min and max. And also if we want to calibrate the sensors, we have a zeroing menu. Instead of a tare balance button, we have a button where we can set the value. So if I wanted to say, let's change this minimum to, let's go with 1000 and the maximum to 1030. So we can see our pressure lines. If I wanted to say that I know these are all actually at 1010 millibar, we can put in 1010 and hit use value, and we can see that they all adjusted to the updated value. Not a big deal for this one. We're not using this mode, but just so you know, this is where you can zero out pressures or set reference pressures, and you change the axes up here instead of it doing it automatically. The rest of the software functions pretty much identically, with one other small caveat. When taking pressure data, it takes a lot longer than force data. Even at its fastest, it'll only take about 10 pressure measurements. It'll only take about 10 pressure measurements per second at the fastest, whereas it'll take about 100 force measurements if you let it. We'll get to that in a moment. So back to the mode we're going to be using for today. We can see this axis zoomed way the heck in because currently these values look like they're really, really noisy, but they're oscillating about a couple hundredths of a pound force and a couple of hundredths of an inch-pound of moment. So these are all very small, even though they look really noisy. But let me explain the relevant sections of the software here. Again, we have this graph. I mentioned that a minute ago. There's pretty much two other relevant sections to the software. We have this section at the top here, which is managing the wind tunnel, the velocity, what it thinks the dynamic pressure and angle is, etc. And then we have this section at the bottom right, which is for taking data and recording it. These function pretty much independently. You can take data with the wind tunnel off. You can run the wind tunnel without taking data. They're largely independent pieces of the software. But let's talk about up here. So we have a couple buttons. We have zero angle, zero speed, and VFD. in order from top to bottom. Zero angle, if we hit that, we'll take whatever the angle is in this box at the moment you press that button and set it as a new reference 0. We can see it said 3.3 degrees a second ago. If we hit zero angle, it says 0 now. If we change the angle over here, it will say 4.6 degrees relative to that 0. If we uncheck the 0 angle button, it's more like almost 8, 7.9, right? So all this does is it sets a new reference 0 for the angle. Zero speed does very much the same thing for dynamic pressure. Specifically dynamic pressure, not velocity. So if we hit zero speed, we see that this goes to not quite 0, but pretty close. And it does that at whatever moment you press the button. So depending when you press it, you'll get slightly different 0 points, depending on how much the pressure is fluctuating. One thing to, again, like I said, it's measuring Q. It is using Q, using dynamic pressure, to calculate velocity, right? Q equals 1/2 rho v squared. The issue with this is it's also making an assumption about what the density is. I'm not exactly sure which value they're using. You could do the math and figure it out, but they're using probably a fairly standard sea level density for this calculation. So what you might want to do is update that calculation a little bit. You can use your own density. Use this value for Q, like it says, but use a correct value for density to calculate your own velocity. And if we wanted to do that, we could use the ideal gas law. Pressure equals density times specific gas constant times temperature. So if you know the gas, you know the temperature, and you know the pressure, you can calculate your own density. This is a wind tunnel that uses air, so we can always assume that we're dealing with air. Temperature, we have this sort of convenient ultrasonic bath over here that reads out the temperature for us. So we can see that this is 22 degrees Celsius right in here right now. You can read off your own value once you come into the lab and get an updated value for that. For most groups, it's going to be between about 22 and 24 degrees Celsius, based on the weather we've been having the last couple weeks. And then the pressure, excuse me, you can find that by looking at the weather station for San Jose International Airport. I believe it's something weather.gov. So I just Google KSJC, which is the 4-letter airport code for San Jose International, and I just KSJC space weather, and I get the weather.gov page, which has the pressure data to 10 pascals of precision every hour, 7 minutes before the hour. So it's like 9:53 a.m., 10:53 a.m., 11:53, 12:53 p.m., etc. So you can use that sort of pressure to update your density and use your own density to calculate a slightly more accurate velocity. So we talked about zero angle. Zero speed does the same thing for dynamic pressure. VFD is a little bit confusingly named, but it basically turns the electronics on and off. It doesn't actually turn on the main fan. It turns on the electronics and the cooling fan that turns the main fan. So if we hit VFD, you'll hear a fan in the background. I'm going to try and talk a little bit loudly to make sure I'm audible over it. But that fan is not the main fan. If we go back here and look right now, the main fan is off. It's not moving. What you're hearing is the cooling fan in the electronics box that takes power from that outlet over there and feeds it to the wind tunnel. So right now the fan's stationary. How do we control the fan? Well, we control it via this fan power slider. I'll turn it up a little bit right now so you can see, but we have a couple ways to do this. We can drag this slider manually, just grab it with the mouse and move it around. Whoops. And don't mind that. And we have, or we could type in a value up here at fan power. So if I type in, a caveat here, we generally don't type in the value directly here. We want to slowly, about that quickly, increase or decrease the fan power. And then we can type in the exact value we want once we get to close to the value we want. We don't want to put a huge amount of stress on the wind tunnel, specifically the motor over there. We don't want to have it impart a huge amount of moment all at once. I have to fix that. We don't want to impart a huge amount of moment all at once, just because we want the motor to last as long as possible. So if we have the fan at power, well, first off, it tells us what velocity we're at. We don't tell it what velocity to use. The reason for this is how much velocity we get depends on what is in the test section and what orientation is it in. If we have something that generates a lot of drag, the wind tunnel will run slower. If we had very little in the wind tunnel or something more streamlined like an airfoil, the wind tunnel will run faster at the same power settings. So, because of that, we don't specify velocity. If we want a specific velocity, we have to increase or decrease the power until we get to the velocity we want. If we are at the velocity we want and we want it to stay there, we turn on speed lock. This makes sure that if we're changing anything in the wind tunnel, the velocity will stay the same. Turning on speed lock tells the wind tunnel, hey, don't worry about fan power. Use more power, use less power, whatever, but keep dynamic pressure constant. So that's what speed lock does. We won't need speed lock for any of these except the flat plate when we're measuring changing angle, because for the rest of them, we want to change velocity. So for the rest of them, we're going to be, if we want to change velocity for the test at hand, we'll increase or decrease velocity by changing power. If we want velocity to stay the same, we'll set it to a power setting and then turn on speed lock. I should mention there is one more way to change power, and that is if you click on this text box and hold either the up arrow or down arrow, it will adjust the power setting accordingly. Based on where the cursor is, it'll adjust different decimal places. So if it's in the middle, it'll adjust 1 percentage point at a time. If it's all the way at the back, it'll adjust 1/10 of a percentage point at a time. And if you put it all the way in the front, it'll adjust 10 percentage points at a time. For specific to the lab that this video is for, if we just hold the arrow key, it'll take about 25 seconds or so to go from 0% to 65%. And then it'll take another 25 to go back from 65% down to 0. So that gives you an idea of roughly how fast it'll increase. That's the top section. It's worth noting that all of these values will show up in the data file. It will record the angle, it will record the dynamic pressure, it will record the speed. We'll look at the data file in a moment. As far as actually recording data, that stuff is all down here. Again, we can use the tare balance button to zero out our force measurements. We have a line item note. So I'll demonstrate how this works in a second here, but we also have a final summary note. So the difference between these is a line item note will show up on every line of data. A final summary note shows up once at the top of the data file. So, just for example, we'll put in flat plate into our final summary note. And for the first few lines, we'll just put in, let's say, test 1. So you'll see how these work once we look at the data file in a moment. How we actually tell it to record data is this column on the right-hand side over here. We have snapshot mode, which and we can change this mode by pushing on this button at the top right, and you can see all the modes we have to work with. Snapshot mode works in the way that if we tell it to take data, it will take one set of data. So it will take one value for speed, dynamic pressure, angle, normal force, axial force, pitching moment. It'll take one line of data. We keep on clicking. It'll take one line of data every time we click. Not the most convenient way to take data from most cases. The second mode we have is sample, where it will take some number of data points with some amount of time between them. This amount of time is in milliseconds. By default, no delay for taking force measurements is about 10 to 15 milliseconds. So we could tell it to take, I'm going to change this to test 2 so we'll see the difference here. I'm going to tell it to take 100 lines of data with no delay. Take data and you can see it count up how many lines of data it has taken. Didn't take all that long to take that. If we tell it to take, I'm going to update that to test 3. If we tell it to take 10 lines of data, 100 milliseconds apart, it'll take about the same amount of time, slightly less. We could also hypothetically tell it to take 10 lines of data half a second apart, and it'll take data a lot slower. You can see how that works out pretty easily. The last mode we have is called stream mode, which does the same thing as sample, except it just keeps on taking data until you tell it to stop. If I tell this to take data right here, it will continue to take data every 1/10 of a second until I tell it to stop. And to stop it, you just push the stop recording button. So, between the snapshot, the sample, and the stream, we have saved 222 lines of data. If we want to save this data in an accessible format, we hit Save Data, and we can choose either US or SI units. To avoid a bug in the software, we get to use US units. Sorry, you can convert when you do your data processing. Because otherwise, if you hit SI units, it sometimes double converts and it'll mess up all of the numbers. If it's in US units, it will at least report them accurately. They're just slightly inconvenient to work with. So we'll hit US units. And actually, before I do that, I'm going to hit cancel for a second so we can see the desktop. Or see part of the desktop at least. Let me move those out of the way for a second here. So, generally the way this works is that it will place the file in the leftmost column at the uppermost spot in the leftmost column. So we hit Save Data, and we hit US Units, and it popped up over here. You can see a new file showed up. Last but not least, we're just going to look at that file really quick and see a couple of things. First off, we have a date and timestamp at the top of the file. And we have our final summary note, shows up at the top of the file. Then we have our column headers and many lines of data. So the column headers, we have a date and timestamp on the left-hand side. The date is accurate, the time is off by about an hour. I'm taking this video at about 1:37, 1:38. Let me double check. 1:37. It's 1:37 p.m. 1:37. I'm taking this at 12:37, 12:37 p.m., but it says it's 1:31. It's a little bit less than an hour ahead. So the date and timestamp is self-consistent, but it's not quite an hour ahead of schedule. We have our dynamic pressure, which in imperial units is going to be in pounds per square foot. We have our velocity, which it is calculating from dynamic pressure. Again, you might want to calculate your own velocity, but it is reporting this in miles per hour with integer precision. That's another reason to calculate your own, because you can get slightly better than integer precision by using this value to calculate. We have the angle that it records in degrees down to the 10th of a degree. We have our normal force in pounds force. We have our axial force in pounds force. We have our pitching moment in inch pounds force. Not foot pounds, inch pounds. Do you remember that? We have a couple of columns that I don't think we'll really be using for the force measurement version of this. And they don't show up in the other version, so we really won't be using these. This is an optional pressure measurement, P. It's going to be 0 for all of these because we're not using it. We have this column that tells us what mode the balance is in. It has two modes. It has the normal mode, which it's currently in, and we can rotate the strain gauges 90 degrees to put it in a side mode. The normal mode is fine for our application, and we won't really need to change this. And then if you have any line item notes, they show up in the rightmost column. Notice these change halfway through. These first ones were from Snapshot and they say test 1. These are from the sample and they say test 2. If we keep on scrolling down, eventually we'll get to test 3, more sample. We'll get to test 4, which was the stream. So the line item note can and will change for some experiments if we're using it. Indeed, for some experiments, it's very critical that we have different line item notes to tell us what's what. So that's a crash course in the software. Again, we have the actual the interface to turn on and off the wind tunnel and speed up and turn down the fan. If we want to keep velocity constant, like when we're changing the angle for a flat plate, for example, we would turn on speed lock to keep velocity constant. We can see a real-time readout of forces and moments on this graph and these displays. And we can make notes and take data with these sections over here, as well as zero out the balances and set the mode for the balance right here. Hopefully this serves people in good stead, and I will end this recording here.